right, in this section, we're going to be working on the law of sines. So this is trigonometry that we're kind of going back to. Don't worry, we won't be doing trig identities. This should be hopefully a little bit easier than that. The law of sines says that sine of capital A over lowercase a equals sine of capital B over lowercase b, which also equals sine of capital C over lowercase c. And if you look at this picture here, all of those capital letters are the angles, and then the lowercase letters are the sides across from those angles. So for example, right here you've got angle A, and then across from angle A is side A, lowercase a, right here. Now, whenever you do these problems, you have to be careful because if you think back to Math 2 when you were learning about congruent triangles, to prove two triangles congruent, there were several postulates and theorems that you could use, like angle side angle and angle angle side and the side side side. There was also side angle side, but one of them that did not exist was the angle side side, and you can see right here that it is quite vulgar. We do not want to use the angle side side theorem because it does not exist. What happens whenever you have two sides and an angle that is not included is that there's more than one triangle that's possible there. So we're going to watch out for this. You'll see sort of as we go along what we'll do with it, but it could cause what we call an ambiguous case with the law of sines. So we have to watch out for that. All right, I'm going to go ahead and do the first problem. So our first problem here, we've got this triangle. We know two of the angles. We know one of the sides. We're trying to find side B right here. So to set this up, I would just say sine of 37 over the side across from it, which right here is 3. So sine 37 over 3 will equal, and then I'm going to say sine of 68 over the side across from it, which is our B, which is what we're trying to find. And so we've got to solve this equation. It's important to remember that sine 37 sine of 37 is just a number. And in fact, I am actually in, let's see, I'm in degree mode, radian mode here. Let's change this to degrees because we'll be dealing with degrees here. So if you're using Desmos, make sure you change Desmos to degrees because that's what you'll be focusing on for most of these. We're not going to use radians very much for these type of problems. If the problem has radians, use radians, but most of these will be degrees. So, I'm going to cross multiply, and when I cross multiply here, I will get B times sine 37 equals 3 times sine 68. So hateful. All right, and so B right here is what we're solving for. Sine 37 is just a number. Sine 68 is just a number. We could type them all in. I think it's a little bit easier to wait till the end to do that. So I'm going to divide by sine 37. And so if I type that in over here into Desmos, I've got 3 sine of 68 divided by sine of 37. And so B in this case is going to be 4.622 if I round to the nearest thousandth there. So that would be the length of side B. Now, in this particular case, we did not need to worry about the ambiguous case that I was talking about earlier because I had two angles and a side. So that has to be one specific triangle there. So this is just my answer, and I'm done with that. Okay, here's our next one. We've got triangle PQR. They give us lowercase p is 28, lowercase q is 22. Measure of angle P is 120, and we're supposed to find the measure of angle R. So in this case, I'm going to draw this this triangle. I know angle P right here is 120 degrees. Side P across from that is 28. Then I've got Q and R, so I'm just going to put Q right here and R right here. I know side Q is 22. Now, in this case, I do have to be careful because I have an angle right here, that 120, and I have two sides, and that angle is not between those two sides. The angle between those two sides is right here at R. So what I have here is I've got angle side. So I have to watch out for this. I'll show you how to check for ambiguous case as we go along. We're going to just set this up like we did the last problem, except for they're asking us for angle R right here. We really can't find angle R because angle R right here, we don't know side R that is across from angle R. So since we don't know side R, we can't find angle R right now, but we could go ahead and find angle Q. We do know the side across from angle Q. And then it's going to be pretty simple to find side, angle R because in a triangle we know angles add up to 180 degrees. So we can just subtract and we'll have the answer there. So for this problem, we are going to say sine of 120 over 28, okay, equals sine of Q over 22. And so to solve this, just like the last problem, we're going to cross multiply. And so we'll have 28 sine Q equals 22 sine 120. Goodness. Here. And then this 22 sine 120, that's really just a number. We could type it in the calculator. I'm going to divide off this 28 right here so I can get rid of it. And so sine of Q is going to equal, and let's go over here and type this into Desmos, 22 sine 120 divided by 28, and we're going to get 0.6804485 and so on. Keep that number right there so that you can use it. Now, we've got sine of Q equals this value. What we've got to do to find that value is we've got to do inverse sine. So we're going to do sine inverse of both sides. And sine inverse just cancels out sine over here. And so I get Q equals, and then over here, I'm going to, we can do this. We can say A equals this, and then we could do sine inverse. I don't know if this will work. A. Yeah, I think that's working fine. Now, you don't necessarily have to do it that way. You could type in this whole number, but if you let this equal A and then type A here, it's kind of like storing that value in your calculator. Of course, you're welcome to use your calculator if you've got one at home, but a lot of us are having to rely on Desmos here. So we'll have 42.879 degrees if we round to 3 places there. So this is our answer. Except for we do have to check for the ambiguous case here. So what we're doing here, if you think of the unit circle, when you look at your unit circle, on that unit circle, if you're thinking of values, we're finding a value right here, which is 42.897 or 879 degrees. So our answer we're finding right here. However, sine is also positive over here in that second quadrant because sine is the y-coordinate. So there could be another value in that third quadrant that would also work. So what we're going to have to do for this, so this is to check for the ambiguous case. So to check for ambiguous case. We're just going to take 180 degrees and subtract the value that we got here. We're going to subtract that Q value. And so if we do that, 180 minus 42.879, we get 137 degrees. So if I go up here to my triangle, we know that Q could be 42.879. There's also a possibility that Q could be 137.121. However, if Q was 137 and P was 120, then you'd have two obtuse angles in this triangle. And the interior angles would add up to be more than 180. So it is impossible for Q to equal this 137.121. So that does not work. So Q only has one answer. We just have 42.879 degrees for Q. Now the question did ask us for R instead of Q. So all we've got to do for that is just take 180 minus 120 minus 42.879, and whenever we do that, that's going to be 60 minus 42.879, and we'll get 17.171. So measure of angle R is going to be 17.121 degrees, and that will be, I circled Q right here. I really shouldn't have. R is my answer right here. This is what the question was asking for. Okay, so in that case, the ambiguous case did not work, so there's only one answer. And really, most of the time, that's what's going to happen. Occasionally, you will have ambiguous case problems. I do not think your Delta Math assignment will have ambiguous case problems. I looked through a few, and I did not see any with ambiguous cases. However, there could be one that I overlooked whenever I was looking through. I didn't do. I can't do all of the problems because it gives you different problems as you do them. All right, so here is another problem, and I am, for this problem, it asks us to solve the triangle. So to solve the triangle, you must find the length of all sides and the measures of all the angles. So for this problem, notice right here that we do have an angle and two sides, and the angle is not between those two sides right here. So we do have angle, side, side. So we're going to have to check for that ambiguous case. But we just kind of keep that in the back of our minds, because first we're just going to set it up like we've been doing the other problems. And so we would say sine of 70 over 25 equals, and then we've got to use side 26, so we're going to say sine of C over 26. And so, just like the last problem, we're going to cross multiply. Whenever we do that, we will get 25 sine C equals 26 sine 70. And so let's divide both sides by 25 to get rid of that. And then, so we've got sine of C equals, and let me get rid of all this stuff from the last problem. We're going to have, I'm just going to call it C equals 26 sine 70 over 25. And we're going to get 0.97728. And so we need to do sine inverse. So I'm just typing in sine to the -1 of, I'm going to use C right there. And so for C, I'm going to get 77.763 degrees. And so that is one of the answers for angle C, but we have to check to see if there is another answer. So basically, anytime you're doing law of sines and you have to do inverse sine, you always want to check to see if you can have an ambiguous case. To check for ambiguous case, you're just going to take 180 and subtract that number that you just got, the 77.763, and we get 102.237. So if I go back up here to this triangle, and we're talking about angle C right here, 102.237 is a possibility for that angle, because if this right here is 102.237, which you can't see very well because I didn't write very well, and this is 70, that only adds up to 172.257. So that means this other angle could be like close to 8, and you've got the triangle adds up to 180. So what we have here is actually an ambiguous case problem. And so that means that one of the answers for C could be 77.763. Or the other answer could be 102.237 degrees. Okay, so you have two possible answers. And to know which one's actually correct, you'd have to take some more measurements on this triangle. So given the information that we have, either one of these could be correct. Now, if I go back up here and look at the problem, this angle looks more like it's 77. It doesn't look obtuse, but we don't want to go on assumptions like that because our pictures are not always drawn to scale. Now, I'm not done with this problem because it asked me to find all the angles and all of the sides. So I've still got to find angle B and side B. Angle B is very simple to find because all I've got to do for angle B is say 180 minus 70 minus 77.763, and that's going to give me 32.3237. So angle B is 32.237 degrees. Now, this is the angle B that goes with 77.763. There's going to be another angle B over here. We're going to have to do this problem twice with using the other C value. So we'll do that in a minute. Now, to find lowercase b, to find side B, we're going to have to set up law of sines again. So we would have to say sine of the 32.237 over side B equals, and I would probably go up here, I would probably use the sine 70 over 25, just because that one was already given to you and you don't have to round any for it. So I'll say sine 70 over 25. And so we'll cross multiply. B sine 70 is going to equal 25 sine 32.231, and we'll divide both sides by sine 70. And whenever we type that in, we'll have 25 sine 32 divided by sine 70, and we get 14.098. So the side B is 14.098. Now that's going to be slightly off because I did round. Oh, it's going to be actually way too. Let's see. That should have been 32.237. Let's see how much difference that makes. All right, 14.191. Sorry about that. Okay, and so that is one of the possibilities. So right there, you have got these answers are one set of possibilities for the triangle. However, you also have the possibility that C is not 77.763. If C is 102.237, that changes what B would be for the problem. So we're going to go back, get rid of these, and we're going to do 180 minus 70 minus 102.237. And so we will get 7. Let's switch back to a pen here. We'll get 7.763 degrees for angle B in this case. And so to set up law of sines for that, we would have sine of 7.763 over B equals sine of 70 over 25. And we could cross multiply, so B sine 70 is going to equal 25 sine 7.763. We'll divide both sides by sine 70. You can see it's basically like we took what we did over here and just replaced that 32.237 with 7.763. And so if we type that in, 25 sine 7.763 divided by sine of 70, we're going to get 3.594. So side B in this case would be 3.594. And so that would be our set of answers for our second set. So I always hate to get an ambiguous case because it means twice as much work, especially whenever you have one where you got to solve the triangle here. You can see that takes quite a while to do. But I don't think you're going to run into this a lot in most cases. So let's continue on and try another example. In this example, we're supposed to solve triangle ABC if B is 17 degrees, C is 46 degrees, and side C is 18. So I'm going to do this one without drawing the triangle. You could draw it if you wanted to. Also, I do not have to worry about the ambiguous case in this particular instance because I've got two angles and a side. I'm going to set up, I will have sine of 46 over 18, and that will equal sine of 17 over b. And so I will cross multiply b sine of 46 is going to equal 18 sine of 17. And so I will divide by sine 46 on both sides. And when I do that, I'm going to have b equals, and I'll type that in, 18 sine 17 divided by sine 46. It's going to give me 7.316. For side B. I don't have to check anything else for that because this is not an ambiguous case. This is not an angle side problem because we've got two angles to start with. That finds side B. We also have to find angle A and side A. Angle A is really easy to find since we have the other two angles. We're just going to say 180 minus 46 minus 17, and we'll get 117. So angle A is going to be 117 degrees. To find side A, I'm going to have to set up the law of sines again. So I would probably use the C's here to help me set this up. Sine of 46 over 18 is going to equal sine of 117 over A. So sine of 46 over 18 is going to equal sine of 117 over A, and I will cross multiply, and so I'll get A sine of 46 equals 18 sine 117. I'm solving for A here, so I'm going to divide both sides by sine of 46. And so A is going to equal, go over here and type that in, 18 sine 117 over sine 46 is going to give me 22.296. And so those are my three pieces that I need to find. Mom. Okay, here's our last one that we're going to do. And this is a problem. These are not actual measurements, but they are an experiment that we would sometimes do in class. That chimney back behind, in between the band room and where you go down to the gym, there's a chimney back there, and so we used to find the height of that chimney, and obviously we can't really do that very well today, but we can look at the situation that we've got here. So Aspen and Gillian look up at the chimney and find the angle of elevation to the top of the chimney to be 56 degrees. They step back 2 meters and find the angle of elevation from that point to be 54 degrees. How tall is the chimney? So this is an example of a word problem that you might see. I love law of sines because it can be really applicable to a lot of things. In fact, if we were in school, we'd probably do a quick little project with this, but since we're not, we're probably not going to. But we've got the chimney here, and if you go look at that chimney, there's a fence around that chimney. So you could not measure to the bottom of that chimney. So you could not actually find the height using regular trig. So what you would have to do is you would have to find the angle of elevation to a point, and they did. It was 56 degrees. And then you would back up some and find the angle of elevation from that point. So that would be 54 degrees. And this length right here is 2 meters. And so we want to know the height of the chimney over here. This is, I'm going to call this H. This is what we want to know. But we do know this is a right triangle, but we only know an angle right here. We don't know the length of any of those sides, nor can we find any of those. So what we could do is we could use this bigger triangle right here, this top triangle. Oh, let's see. Here. This triangle. And we could find, we really can find either this side or this side right here. I think that I will just find, this side right here. I'm going to call that X. And so I'm going to use this triangle right here to find X, and then I can use X to find H. So first I've got an angle right here. I need this other angle, and since this angle and this angle make a straight line, I can do 180 minus 56 degrees. And if I do 180 minus 56 degrees, I'm going to get 124 degrees for that angle right there. And then if I do 180 minus 124 minus 54, I'm going to get 2 degrees up here in this top angle right here. So I'm going to use law of sines for this triangle right here because it is not a right triangle. So I have to use law of sines. I cannot use regular trig. So I'm going to say sine of 2 over 2, 2 degrees right here, across from 2 meters right here, is going to equal sine of 54 over x. And so we're going to find x. We're going to cross multiply. So we get x times sine of 2 equals 2 times sine of 54. And to solve that, we're going to divide by sine of 2. And so whenever we type that in over here to the calculator, we would have 2 sine 54 over sine 2. We're going to get 46.363. And that's meters. But that is the length of side X right here. So we know this side right here is 46.363. So that is the length of this side. We're looking for the height of the chimney. So we have got to find the height right here. We could use law of sines again. We could say sine of 56 over h equals sine of 90 over 46. Or we could just use regular trig because this is a right triangle. So I'm going to use regular trig in this case. The opposite side is h, and the adjacent side, the hypotenuse here is x. So opposite and hypotenuse is going to be sine. So I'm going to say sine of 56 is going to equal the height divided by the x value that we just found, 46.363. And so we multiply both sides by 46.363. And so if you type that in, we take that 46.36267401005 times sine of 56, we're going to get 38.436. So 38.436 meters in this case. So that is our height of the chimney, 38.436 meters. You can do this pretty easily on your own. Tomorrow, your assignment is going to come from Delta Math. The assignment with Delta Math, I don't think is going to have any ambiguous cases in it unless I overlooked that whenever I was doing the problems. We're also going to learn law of cosines. You'll have an assignment with that, and then eventually we'll get into doing a few more word problems with these sort of things. So that's sort of what you'll see coming up.